He's so tilted.
Min, I don't want you to get too used to being absent, so I'm going to make it inconvenient for you. The whole thing is kind of slanted down from the angle.
It's like you're communicating.
So this is, I know that we talk, a lot of this is review, but it's worth going back over and talking about. The barometer works like this. Torricelli, way back this long time ago, took a long tube, and it was a long tube, about 1 meter long, fills it up with mercury, and turns it upside down, and sticks the open end of the mercury upside down into a pool of mercury. And what he saw was from the closed end, which was now on top, the mercury fell, but it didn't fall all the way, it just fell a certain amount and sat there. And Torricelli measured over time the height of the column of mercury, and he noticed that different days, the mercury level was a different height. He noticed when the rain came that the mercury was at a lower height. It would fall. And when it was sunny for several days in a row, the mercury was real high in that container. So he concluded that the air pressure, as it changes, it was affecting the level of mercury in the barometer. And so he was able to actually measure the pressure of the air with the barometer. And so that gives rise to the oldest unit of pressure, and that would be the millimeter of mercury. How many millimeters high is that column of mercury? We can't have a mercury barometer in the school. That is absolutely the best kind of barometer to use. It's the most accurate.
But mercury is poison.
It is poison, yeah. And there's a lot of, your parents and grandparents may have played with mercury when they were younger. I know I did. One time I remember having free mercury and picking it up and having it in my hand. And it is so fascinating. It's really a shame that it's so toxic. Yeah?
They didn't realize it was toxic until like 1900s.
Yeah, I don't know if they knew how toxic it was. Yep. But it is pretty bad. Like if you have a cut on your hand and just a little bit of mercury gets into that cut, it's lethal. It could kill you. What? So it is quite dangerous. Even the vapor, if you breathe the vapor, it's bad. Back when I started teaching in the 90s, man, every so often, not every week or like that, but every so often, I'd be driving to work and they'd say, X school in Detroit is canceled today. And it was because they had a mercury spill. I think kids kind of got wise that if they broke a couple of thermometers, they would have to evacuate the school and they'd get the day off. Maybe a couple of days off. Because they would evacuate the school. You can't be breathing this stuff and, you know, your kids and the whole thing. And so they'd have to bring hazmat in to clean up the mercury. So at that point, in the mid-90s sometime, they outlawed mercury. No mercury in schools. If I were to have a mercury barometer and got caught with it, I could get busted or fined or whatever. I don't know if I'd get fired, but I would be in the legal system. Yeah?
Why do they use mercury?
Because it's very dense. If we used water, we would need about 30 feet, a tube that's about 30 feet tall. So we're on the 3rd floor right now. We'd have to be on the ceiling, the roof, and kind of looking at the level of mercury if it were water. And the reason for that is because water is 13 times less dense than mercury. Mercury is real heavy liquid, so you know it falls and it's got quite a bit of weight. A water barometer would be way too tall to get that same mass. Yes, Emily?
How would they keep the mercury from spilling out of the tray, though?
Yeah, he would not have it all the way. I mean, this picture is kind of bad because it looks like it's all the way up. And if any falls out, it's going to slop over. It would not have been filled that much.
Would it just be like really high then?
As long as the open end of this tube is in the pool of mercury, then it's fine.
Also, like, would you need to like have a little space between the bottom and like the?
Yeah. He doesn't. It would be sealed off if there wasn't some space in the bottom. Yeah, he would have had it clamped so it was kind of suspended in the pool.
Oh.
Yeah, this is a good question. Yep. Ben?
Is there any other denser liquids that they?
I don't know of a denser liquid than mercury. There might be, but I don't know.
Melted gallium.
What about gallium?
Could you use like melted gallium?
It's not very dense. Gallium is right under aluminum on the periodic table, and it wouldn't do the trick. So that's why I use mercury. Okay. I'll just put that back. So the millimeter of mercury is a common unit of pressure. These days, very commonly, we'll not use millimeters of mercury, but use the unit torr. You have to go?
Yeah,
Carol?
Good luck, Carol.
What was today?
Good luck.
Oh yeah, you got your freshman sophomore. All right, Carol, rock it.
Beat all those.
That's right. Don't get beat by a freshman, Carol.
Okay, well.
Good luck. Yep. Okay, so anyway, the book will use a lot of problems where the pressure is in torr. So I want you to see that, get used to it. We'll talk about the R value for the ideal gas law. Millimeters of mercury, torr, it's the same unit, or same value of R. Okay, then and by the way, commonly we'll use kilopascals too. The pascal is the official metric unit of mercury. It's like the base unit of pressure for the metric system. But the pascal is a very small unit, and atmospheric pressure would be 101,000 pascals. So they use kilopascals, and you might remember standard is 101.3 kilopascals. Does that number come back to you?
Yeah.
101.3. What is standard pressure in torr? 760, right. You got 76 centimeters is how tall. It's about that much. Back when I was student teaching at Rochester Adams, they had just gotten a mercury barometer. And I was only there for a year, but I wonder how long it was before they had to kick it on. And they're expensive. Mercury is expensive. And so they were all proud of this mercury barometer that they had. What?
That much mercury.
Yeah, that's a lot of mercury.
Yeah.
Yep. If that thing broke, man, that would be a big
How
mess.
heavy? It was probably pretty heavy.
It was. Yeah.
Wait, so it's only using in schools, or is it just
Only in schools. Yeah, we can't have it in schools. Like if it was found in your home, nobody would come in and say, "Oh, the police are going to come get you for having mercury."
If you spill mercury, like, does anything happen? Like, does your desk melt or something?
No, it's just that if it's not in a sealed, closed container, then you could be breathing the vapor. It does evaporate, and it could be toxic. Mercury vapor does get into your system. It gets into your nerves and affects your nerves. It gets into your brain.
Does
What?
anyone die?
Oh yeah.
There's this one scientist, she was like working with some organic mercury, she got like a single drop, and it went through like 5 layers of gloves.
Yeah, she had gloves on. I remember hearing about
5
that.
layers.
Just a drop of mercury. Yeah, got into a hole in her glove and she died. Yeah.
Back in 3rd grade, I actually broke a thermometer.
So you got to play with the mercury?
No.
Did you feel it?
No.
Oh.
I just broke it, it shattered on the floor, and the teacher just wore gloves and cleaned it out.
Yeah.
Sketchy.
Yeah.
Is it like liquidy?
It is. It's liquid. Yeah, but it's real heavy liquid. I wish that you could play with it because it really would surprise you. Like if you have a baby food jar with mercury, you pick it up and you're like, whoa, this thing is heavy because it's so much more dense than water. We're used to water. That's our experience with liquids is water. Mercury is way different. And if you spill it, it kind of bounces around in beads. But it's a liquid.
So it's really cool.
If you ever have the chance, just play with it for a few minutes, then put it back.
Okay.
Put some rubber gloves on though.
Does it
Yeah?
smell good?
How do they
I don't know
prevent
what
the
this smells
mercury from evaporating then, like in the barometer?
This is back in the 1600s. He had no idea. So he would have just left it out, I'm sure.
Well, when,
Why?
oh, never mind.
You ever heard of the Mad Hatter in Alice in
Yeah,
Wonderland?
it's because
Yeah,
of the hats are
mercury.
made out of.
Yeah, to make the brim of the hat
Yeah.
flat.
So they're going mad.
Yeah. They would go mad. They'd go crazy. The people that worked in the hat factory because they set the hat down in a pool of mercury.
It's so dark.
Pretty sure mercury
I
poisoning
watched a
is
YouTube
different.
video.
Yes. Yeah.
It's called
So it does
Blood
affect your
Rain.
nervous system and brain. It makes you paranoid, and yeah, but it can be lethal. So it's not cool. Okay, so let's just go through. Now I'm going to look at the clock and say, oh shoot, now I've jabbered my way out of the lecture. We're going to go through 3 scientists. You're going to expect that you know the 3 scientists, but I'm going to surprise you at the end. Robert Boyle came up with Boyle's Law. Without giving the equation, the mathematical equation for Boyle's Law, you remember what the relationship between volume and pressure are for a gas? If you've got a gas in a sealed container,
Pressure goes.
what is it? Yeah, how are they directly or inversely related? If one goes up, the other one goes
Pressure
down.
goes up, volume goes
Imagine a sealed container that can expand, like it's got a piston or something that can expand in and out. If you have a container of this sealed gas and you squash it down so the volume is going down, what's happening to the pressure?
Increase.
It's going up. Yeah. You're squashing those particles together more. They're hitting the walls of the container more frequently. Yeah? More collisions of the particles on the walls, that means the higher pressure. You're exerting more of a force. So, we would express Boyle's law in a graphical form like this. As the pressure is high, the volume is low. As the volume is high, the pressure is low. Inverse relationship. So that if you have an inverse relationship and you take one of the variables and invert it, what happens when you invert the inverse?
It's the other. It's reciprocal. What? Right?
This is a reciprocal.
So it.
Well, yeah, it would be a reciprocal of that relationship. Yeah,
So it go up.
like that. Yep, it'll be a direct relationship then.
Why be more curved?
No.
Really?
A direct oh, this one?
Why
Yeah, that's probably more curved. This is going to be a straight line though.
Ah,
A direct relationship is going to give you a straight line. Now, could we come up with an equation for this line?
Yes.
Yes. A general equation would look like this. V, that would be y, it's on the y-axis, equals the slope, we're going to call the slope k, times x, which is 1 over pressure. It goes right through the origin, so we don't have a y-intercept. Yes?
doesn't like temperature or something like that go up?
Yes, the slope would be affected by the temperature. Yep. So I'm just giving it some arbitrary number k at some temperature, some non-zero temperature. Yep.
So 0 Celsius probably.
Yeah, something like that. Yep. Okay. So we're going to have this as one of our relationships. You got that written down. You'll see. We'll come back to that. Next one. I love this guy, Jacques Charles. Look at that hair. Isn't that good? I wear my hair like this because if I had that, I would have long hair. But mine's straight. Mine is totally straight hair. Matt, you got good hair. Mine's
Come
not.
on, man.
Dinah, look at that hair.
Hair model.
Come on, guys. Kevin's got a little wave in the beard. You guys all have good hair. Mine is just straight. I can't do anything
What are
with
you
it.
talking about? Don't dish
J Deep. You got Anish. Nathan, all you guys, you got perfect hair.
Mr. Moore, don't diss yourself. You got beautiful hair.
Oh, I'm happy with this. This works for me. But anyway, look at his occupation. He wasn't only a physicist, he was a hot air balloon guy. And who better to come up with a relationship between temperature and volume? Isn't that what a hot air balloon depends on?
Hot air, hot man.
How do they make the balloon bigger? They heat it up.
With helium.
So anyway, we have a relationship between volume and temperature, discovered by Jacques Charles. And so this is a direct. We would all know, if you heat a balloon or some expandable container up, out it goes, it's going to expand, and so we'll have a direct relationship between these two.
Mr. Moore, I like your sound effects.
So we have a relationship here that we can express as an equation. Volume, the y term, again, equals k. The slope, we'll call another k. K in science is just some arbitrary number used as a constant. It's the slope, in this case, it's constant value. I could call it k prime because the two k's that we've seen are not the same. But just know that it's some slope, some constant number.
KT. KT.
KT? He's talking about you. KT. Two KTs. All right. Now, you were expecting, you saw Robert Boyle, you saw Charles, you were expecting Gay-Lussac, weren't you? I don't have it for you. What I do have, you recognize that guy?
Yes, the
Made the
avocado
mold.
head.
That's me on Schoology. Do you get messages from me on Schoology? You see my-
His brain is literally like 3 times his chin
He's too smart. He's too
She's
smart.
not a
for his life.
5 balloon.
I wish I knew what was going on with
That
Avogadro
actually
the
was
day
his
this
design.
painting was done.